Hello? Yeah. Hello, everyone. Can I ask the last 2 to 3 rows to come a bit more to the front because it's way nicer to talk to a full front row for the lecturer. So please stand up and come a bit more to the front.
COVID time is over, huh?
Ja, het is altijd wat last, maar ik vind het zelf ook altijd fijner praten als de mensen meer vooraan zitten.
We beginnen gewoon alleen met stoelen vooraan en dan...
Precies, eerst afzetten. En, ja, precies. Nou, even kijken. Ik zal hem iets hoger zetten voor jullie, want anders dan... je kan hem er ook afhalen als je wil.
Is goed.
Want ik ben natuurlijk maar een klein meisje. Ja, je kan hem er ook afhalen als je wil voor het praten. Then I would like to thank you all for coming, and I would like to give the word to Tim and Janneke from Scheldebouw.
Yeah, thank you. Thank you. Welcome everybody to this lunch lezing. My name is Tim Debats. I am a lead concept designer at Scheldebouw. That means that I'm busy with concepts for new projects that we do. I do part of the tenders and the technical sales part. This is my colleague Janneke. She's our sustainability lead for Scheldebouw, and she also works in our overall group of companies. Maybe to start off, is anybody familiar with Scheldebouw or what we do? A little bit? Maybe raise your hand if you do. Never heard of us ever before? Okay. We are world's biggest contractor in facade systems. We mainly work in large iconic buildings, the most prestigious towers. What we mainly do is customize facade systems, so we do not have any products off the shelf. We design everything from scratch together with architects, consultants. And maybe just to give you a little bit of context on this presentation, we would like to just show you a brief video of what we do, our brand movie, and it might give you a little impression on what we do.
City skylines, shaped by iconic statues of modern architecture. Glancing up at these shiny facades often feels magical, but it is not magic that creates these monuments of the future. At Scheldebouw, we know it takes expertise, experience, and devotion to create skyline-changing buildings. Creating something outstanding requires new ideas and tailor-made concepts that make them real. That's why we don't choose paved roads. We think in possibilities. We breathe challenge. And we reshape technology to create new visions. Our engineers design solutions that transform ideas into remarkable curtain walls that protect building inhabitants from the elements outside. We have an uncompromising focus on excellence, and we test our designs in ways that exceed your expectations. At the core of our manufacturing facility lies customization and a commitment to perfection. By tracking everything we do, we keep a tight grip on even the smallest detail. It's this kind of commitment to excellence that is reflected in the exceptional quality of our panels. In fact, excellence is of such importance to us that our assembly area maintains clean room standards. Driven by perfection, we leave nothing to chance. Our daily quality control makes sure every component complies with our quality standards. Our commitment extends far beyond our facility floors. Our large warehouse allows for meticulous planning on even the largest projects. On-site excellence is just as important to us. Our unitized panel installation minimizes time on site while guaranteeing thorough and precise installation. You might be wondering why we are so devoted to excellence. If the skyline of the future was your canvas, wouldn't you be?
So this shows a little bit what we do. We are part of the Permasilisa group. This is a worldwide group of companies who specialize in customized facade designs. So in a nutshell, what we do, we start off with architectural concepts. We discuss with architects, main contractors, developers, and we come up with a plan for them, how to engineer the facade. We source all the materials, we do all the engineering, all the calculations. We all do this in-house. We do all the fabrication, logistics to site, all the quality control, installation, and also the after-sales services. So we really do the whole story, A to Z, full package. Where do we do this? We are mainly, our main market is UK, London. They have most of our portfolio of buildings. We operate actually throughout Northern Europe, Scandinavia, Eastern Europe, Poland, Hungary. And sometimes we also have intercompany projects where we exchange projects in the USA or in the Middle East, where we help our sister companies executing these projects. Where are we located? We have two companies in the Netherlands. One is in the south, in Limburg, in Heerlen, where we have a design office, and we have one in Middelburg at the coast in Zeeland, where we have production facilities and also engineering capacity. With those two operations, we serve the whole Northern European market. Maybe making the link to sustainability. What we do is inherently sustainable. We have always done this, and we are tweaking this now to serve new sustainability ambitions that we see on new projects. We only work with customized solutions, so we don't have off-the-shelf products. Everything we do is fit for purpose for that specific project. So we do not design anything that is not required. Everything we do is really exactly for that specific project, and there's no excess material used. It's calculated exactly to the static demands, thermal demands for that. Everything we do is also in a modular assembly principle. So the unitized facade panels that we build, they can all be assembled and disassembled with materials that can be reused at a later stage. We have always done it like this because it actually serves our production process best. In the new economy, this really helps us. At the end of life of a building, we can actually take those materials apart again and reuse them. With our engineering expertise in-house, we try to also combine these sustainability ambitions with any of the other engineering requirements. Usually the architect has his very specific vision of the building aesthetically, also for the function, but there are also a lot of building regulations which differ per country. Fire regulations, we have the structural demands, thermal demands, that all needs to be combined, but still trying to keep the sustainability ambitions up. Everything we do is produced in a factory, so we don't do anything on site, or we try to minimize everything we do on site, purely because that's a better production environment. The weather does not really influence our quality. There's good lighting, there's good access. You can really warrant the safety. And that really ensures that our products have high quality that can also last long, do not have to be replaced after 10 years. And in the end, we also offer service and maintenance for projects which we deliver, so that we can actually maintain the lifespan of the building, and maybe we can also upgrade it or extend it. The projects where we do this for are very diverse. So we do not define the principles of the building. The architect does that. Materials are prescribed to us. We try really to work with these materials, analyze them, and maybe offer something alternative to the client. But there is not, let's say, one type of project that we service. Janneke.
So let's zoom in a little bit on how that works in our project. So what you see is a huge diversity of material use, of shapes and forms, and that if we look at sustainability and how that works in our company, that needs to be fit for this for these type of projects. Let me show you a personal inspiration I have. That is our Queen Maxima. Might at first glance not be so obvious, but let me explain you a little bit more. What I think that our Queen does very well is that she takes her role as being in the spotlight, being an example to the public. She takes up that role very seriously. On the one hand, she's under close scrutiny of how she looks, but on the other hand, she also understands that it is not acceptable in our society anymore that you buy a dress to wear once and then you throw it away. So for instance, here you see the famous design by Jante Miniau, who also designed her wedding dress, and it's made of former postal bags. Another example, here you see the jeans jacket she's wearing, and on another occasion her daughter is wearing the same jacket, and you also see the red hat. She wears it in both pictures. Another example, to the left side you see the dress in a bright yellow color, and then a few years later she had it dyed in a darker yellow color to make her appear new again. And I think that is something that is actually can be a good example for the business we are in, because we are also making these iconic buildings that are in the spotlight of the skylights of the big cities of the world, and in a sense we are also dressing the Queen. So I think this could be an example for our company. But how to do that? I will give you some more insight in that. Because for instance, if you look at the dress that has been dyed, we don't know if this is really sustainable, because maybe they used some very toxic decoloration, or a dye that is not so good for the environment. You don't know that if this is just window dressing, if it's just for the appearance, or that it is really a sustainable solution. And that is something I think we need to be aware of, and that is very hard to judge sometimes. So how do we avoid cherry picking and greenwashing in the world of sustainability? Because I think that is a struggle all of us have. How to balance all these effects that maybe go in opposite directions. And it's a challenge we also have as a company. The answer to that is LCA, a life cycle analysis. Of course, there can be a lot of discussion about the method, and there's pros and cons and how to do this and how to do that. But on the other hand, it is the best method we have in industry. It's widely accepted, there are standards, and of course there's still discussions, but this is a way to balance all the environmental impacts a product has during its life cycle, and in a systemized and a standardized way. So that is why we also embrace this method in our company, but the real challenge I think at the moment is to not let it turn into just another certificate, just another document that you can put in your drawer, but how to turn this into action. That is something I think is very important, and I would like to show you how we do that, how we went on this journey at Scheldebouw. So zoom out a little bit. What we saw in building and construction industry in the last years is that the focus was on reducing carbon emissions during the operational phase of the building. So reducing heating and cooling loads. And we did that by adding thermal insulation, adding solar shading, adding solar panels. So in general, by adding material. And so we are also adding, we are reducing the energy use during the use phase, but we are adding energy use before the building was there. That is embodied in the materials we used. So there's more and more attention to that now. That is what we see around us, that needs to be taken into account in the balance. Here it's shown graphically. So to the left you see all the energy use and all the environmental impact before that the building was completed, that is in the materials. Then we have the use phase. In this case it is 60 years lifespan, and you see all the energy use used to heat and cool the building. That is the orange part. They did it very nicely actually, because you see it varies a little bit over the years, and that is of course because the weather is not always the same. And then you see these pink spikes through the life cycle. Those are the replacements of components and maintenance impacts. And then at the end of life in the old economy, the building is demolished and the materials go to their end of life station. So if we as a facade manufacturer want to do a life cycle analysis, what does it take? Well, actually collecting a lot of information. So we need to know exactly which materials are in the facade. You see here the big list with all the material types, kilograms of material in one facade panel. And then you need to know where are they produced, with which processes, how were they transported to our facility in Middelburg. Then for the production facility in Middelburg, you need to know how much energy was used, which processes took place there, how many waste was produced, and then you have the transportation to the building site. You also need to know which activities go on there. And then we need to do this for every project, again, because we don't have standard products. We cannot do it once and have a document that covers it all. We need to do it for every project individually. So that is a challenge, let alone if you are the client's consultant who needs to do this for the whole building. So not only for the facade, but for the complete structure, for the MIP installations, collect all this information from all the subcontractors and bring it into one calculation. I think there's a big risk of misinterpretation, or that things are left out, maybe things are double counted. In any case, a lot of coordination is needed. And that is why we decided at Scheldebouw to take these calculations into our own hand and make one document of it, provide it in one clear overview to the client as a service, but also because we think that we are the ones who know best what's in our product, and this knowledge helps us to advise the client better on the environmental impact and maybe advise them which decisions could make the project and the product we make better. So that is why we provide this in one document now, and we do that for every project again. The first document has now really been verified by a third party and published online. This picture is not because I like it so much to be here on the screen so big, but it is because I'm really very proud of this moment. It was the first official EPD publication, and I am here together with the reviewer who hands over the document. But still, as I said, it is not the most important thing to have a nice document that you can put in the drawer, but what can you do with it? I don't know how familiar you are with these EPD documents, if you ever saw one, but basically it's just a huge table with a lot of numbers. So what we try to do is provide it in a nice overview to make some to get a better idea of the impact of the different components of the facade. So you see here the pie chart, and I think what you immediately see is, maybe you cannot read it, but the blue is glass, the orange is the aluminium frame, and those have by far the biggest impact. And then there's other materials that have a lesser impact, and you also see the transportation and the energy use. I think it's very important to say that this is not the Scheldebouw performance, because we make every project, the facade is specifically for that design. It is based on the choices that were made for that project, and so we first start with calculating what would the impact be if we do not take any specific measures, just take the design of the architect and calculate the impact if we did nothing special, and start from there and see where you can make a difference. So this is trying to define an honest baseline and taking into account everything that is in the facade. But yeah, so one calculation, 271 kilogram of CO2 per square meter of facade. Is that a lot? Then you still don't know exactly what to think of it. So we first start comparing it. This is 3 different facade types of the same building. So at the top you see vision panels, so the most of it is glazing, and a small part at the top at the floor edge is an opaque part with some insulation. Then the next facade type is completely opaque, so it is you cannot see through it, and the outside is an aluminium panel, then some insulation, and to the inside you have a steel panel. And then the third facade type is a combination of both of them, and also big protruding fins to the outside that were designed to provide solar shading for the building. So when you compare those 3 facade types, you can see them here graphically. You see that the first 2 are more or less equal in their environmental impact. You see a shift between the glazing and the opaque, but they are more or less equal in total. But the third facade type with the external fins has a much bigger impact per square meter of facade. So that is something that is very good for us to know, but on the other hand, it was a calculation when the building was already finished, and you cannot do much anymore. So that is nice knowledge, but how can you bring it into practice? How can you use this in the new projects to drive the decisions there? Let me show you that. So I have here a new project that is just being designed, and we are still working on it, and we have 2 options. To the left, it's a design much like the first one in the previous slide. So it is a vision panel with an opaque part above it, and nothing special added to it, and you see the environmental impact in the left bar. Then to the right, we have another variant with big fins again to provide shading. And you see the yellow part is added in the graph, so that actually adds a lot of embodied carbon. If then our client asks us what can we do to reduce carbon, there's at the moment we are seeing a lot of clients talking about aluminium billets that have been produced with lower carbon production methods, and it is actually quite a hype, I would say, that all the aluminium manufacturers are now trying to get hold of these billets and want that in their project. But there's actually quite a limited amount at the moment that we cannot do all projects with those aluminium billets. There's just not enough of it. And if you look at the impact of that, so to every variant, I now put one bar against it, showing the impact of using those low aluminium billets. You see that the impact of that decision is actually not so big as the impact that the fins have. So I think this is something that is valuable information for our clients, to show them that you need to start looking at your design first before you take into look at the supply chain and take these, I would say, last resort methods. So this is something that we do for every project, and we look at the specific questions there, which options is the client looking at, because I'm still not saying that the right option is not good, because the fins are there for a reason, maybe to reduce solar ingress in the building, so maybe to reduce the cooling loads, and might, if you add it all up, still be a good decision to do. So it is always a very complicated matrix of all factors that influence the decisions in your project. That need to be taken into account, and you need to know what the client thinks it's important, and provide all the information in such a way that they can take their decisions in a best way that is possible for them. So that is how we use these calculations now in our projects, and we try to influence our clients' decisions into making more sustainable decisions. I would also like to look a little bit further into the future, because, well, this is not the end, this is just the starting point. And
Maybe also good to note that if we talk 5 years ago, there was no demand for any global warming potential to get on any LCAs or any EPDs. There was just no demand for that. So all the sustainability ambitions that somebody had was nice, but you could offer this to a project which would only, let's say, be more expensive, and you would never win this project. Now there are actually performance requirements, just so like there are thermal or acoustical performance requirements. There is a certain goal, at least, that you have to aim for. So as a company, you can also be aiming for this, and you can actually be competitive on sustainability, and somebody is actually paying for it. So this really changed the market for us as a new specification that you can actually perform on. We started measuring it. Now often it's measuring, but now it's also shifting to measuring the concept design, and then trying to make decisions, changes, so that actually the global warming potential comes down. So it's not only registering, it's also really making an impact, and it's a competitive advantage if you can. So that's really, I think, a very important change that we see in the market now that has really a good effect on sustainability.
that clients are willing to pay for it, yes. Up till now, it was just give us a building that performs according to the regulations, and for and as cheap as possible, please. But now you see that this is changing, that clients want to take more responsibility and are forced to do that by regulations as well. So that's how we try to use this instrument. But this is only the impact until the completion of the building, that when we hand over it, we hand it over to the client. But of course, the LCA method goes through the full life cycle, and there's a lot more potential to it. So what we would like to do is close the loop, take also the impact in the use phase into account at the end of life. So try to close that. Because in the old economy, it was like one EPD, one life cycle here, draw a straight line between it, and start again with a new canvas. And I think that does not hold anymore for the future. So the existing built environment will always be the basis for the new project. So that is what you see here. A continuous cycle of materials, and the end-of-life materials of the one project are the resources for the new project. We are just exploring this. To be honest, I personally don't believe any person who says they have the solution and they know everything. I think we are all just struggling forward and finding our way how to tackle this. But I'll give you a short overview of what the developments we see now. So I think these are the options you have if you look into circularity. You could use a full facade, one-on-one, take it from one building and put it on the next building without changing it. That would be a very theoretical option, I would say. Another option is take it apart and reuse the components. A third option is separating all the materials and recycling it. And the fourth option, going to landfill. I don't think it is acceptable anymore. For the recycling, we see that a lot of initiatives are already ongoing. So we have the Alueco that is recycling, collecting aluminium to recycle it. We have Vlakglas Nederland, who is collecting glass to be recycled again. And it's actually quite challenging to take materials that are in a building and give them a new use in a building again. For instance, glass in practice, if you take it off a building, it usually becomes beer bottles. And it does have too many impurities to be vision glass anymore. And that is the challenge that these initiatives are trying to tackle at the moment. And continuous developments are ongoing. Then we have component reuse. Actually, we have some experience with that as well. The Koningskade building in The Hague is a building our company did in 1967, and there was a renovation recently. The glass they took off was actually only for safety reasons, not for quality reasons. They took it off, so it's 10 millimeters thick glass panes, and they were used. They were cut to size, and they were reused again on the natural pavilion, the Dutch pavilion, on the Floriade exposition last year. So we have some experience with that. Also, the reuse of complete facade panels. The One Triton Square building in London was also a building that our company did in 1996, and those facade panels were taken off, taken to a factory to be cleaned and then put on the same building again, but then one level higher. Was quite revolutionary, and I think there's a lot more to come in this sense. Because I think if I look at our company that is used to using different materials on every project, putting up a new factory line for every project, I think we are really fit to also try and tailor. If we have an existing facade, take it off a building and then make it fit for a new purpose. So take it back to the factory, take it apart, clean it, replace some components, maybe cut it into a different size and make it fit for a new building. And I think those are very interesting developments, and we like to see more of that. So why not make it into a tiny house or make a new, smaller office building of it? The City Tower building you see to the left is, so it's the Citibank in Canary Wharf, London. They are currently renovating this building, and the building owner took the decision not to fully take off the complete facade, but just a few elevations in the middle, a few at the top and a few at the bottom. Only take off the facade there, keep the rest in place. So that means the facade is still good, I would say. And only replace it there with a different facade because they want a new look and feel, and because of working in an office has changed quite a lot in the recent years. That is their goal, and they decided they don't need a complete new facade for the whole building for that. But so the facade panels coming off, I think it would be very nice if they could get a new purpose, a new destination somewhere, and not be thrown away as waste. But we don't have the solution yet. So I think this is a big challenge for all of us, and I'm coming back to where I started. I think that our queen can be a big example for us and for our clients, because we have a responsibility to show the world that it is not necessary anymore to buy everything new and throw it away and still look good.
Yeah.
So that was it. If you want to contact us, we don't have the paper cards anymore, of course. We have the QR codes. It's me to the right and Tim to the left. And if you want to contact us, you can find our information here.
Are there any questions, maybe? Yeah, we do that a lot. I think it started mostly in the UK, in London. They started with the BIM models probably already 7-8 years ago. What it mostly, the link mostly to LCA is to capture the material, the data in there. So we use BIM models throughout the whole process. All the final layouts of panels that are drawn in Inventor, they are put in the BIM models of the client, of the main contractor. He collects that also from all the superstructure, from all the MEP equipment. It's all put together, and nowadays they are used for service and maintenance. So you can click on an item and you can see how long has it been in place, when is it due for any revisiting, when does it need to be replaced. And I think that in the future the LCA data will also be tracked in this model, so to say. Any other questions? Very good question. Yeah. In the 70s, 80s, way before we were there, the big market, or a big market, was the Netherlands. But if you look at the type of buildings that are built in the Netherlands, architecturally, they have gone down a little bit. That's because the budget is simply not there anymore. When you look in London, you can't even compare London to the UK. It's purely London. When you see what is being built there, there's just much more, let's say, square meter rental or sales price. So they just have much more budget to make a very extravagant facade. So you will also find, let's say, the bigger architect names there, and they just have, let's say, more part of the budget for fanciness. That's also where you see the struggle with sustainability ambitions. When you have a lot of features on the building which are purely aesthetical, but they really have a lot of embodied carbon, that is kind of a clash. So we have to also look for the solutions there with these architects. What looks nice, what still is this iconic building, but how can you actually make it in a smart way, not to consume all these unnecessary materials? So it's mostly the prices that have pushed us there.
And the scale of the buildings, I would say. We need
Yeah.
a certain scale to set up a full factory production line
Yeah.
to be feasible. Well, it's also related to price in
Yeah.
the end.
But there's when you have a building of, let's say, 5,000 square meters, very often standard systems are used, like Schuko or Wicona, off-the-shelf system. When you have a building of 20,000, 50,000 square meters, then the customized designs really pay off. Then you really get your money back for the engineering investment that you put in it, then it's really optimized. And they mostly build them over there. But in the rest of Europe, we are mostly in, let's say, the capitals, where here and there a project pops up where you have really a big investment. Then we are competitive. We also see that there are other companies who can do the other market better than us of these standardized systems. So that's a bit the niche that we went into. Yeah. Anything else? At the moment? Well, this is very new. So now, when elements are taken off the project, if they ask that is already very new anyway. But then actually nobody knows what to do with it. Because when you take panels off, let's say you take one of those Citibank, you have 10,000 square meters of facade that you take off. Most projects aren't even 10,000 square meters. So we are really looking for what can you actually do with this. The most feasible option at the moment is trying to take those panels and refurbish them, meaning you put some new gaskets in, you put some new ceilings in, and you reuse them as is. But you have to look for 4 or 5 different projects to put them on. Makes it very difficult. The best option at the moment would be to maybe take them apart and at least use the aluminium again for aluminium for construction industry, the glass for the construction industry, and separate them like that. But nowadays, when you take a building apart, it just goes to the dump mostly. So
Maybe good for the perspective that the curtain walls, as we build them now, are maybe 20, 25 years old. So the first curtain rods are just coming at
starts
their
now, yeah.
end of life. We don't have the project that is from the 1967 is not like the facades we do anymore. So it is a new question actually.
Yeah.
Well, thank you everyone for coming. If you have any questions left, don't be afraid to come to them because they are willing to ask to talk with you. If you need your My Future Points, in the back there are 2 papers laying where you can write down your own student number and your name. Please only write down one. And thank you for coming. I hope to see you by the next one.